Let's now go over local extrema. So, starts off saying a value of input where a function changes from increasing to decreasing as we go from left to right is called a local maximum. Now, if it's plural, it'll say maxima instead of maximum, but same thing. And so you can see here, we have a local max. As it is changing from increasing to decreasing, this is my local max spot. Now, I want to make it very clear that this is not the absolute max of the graph because this graph is going to keep going up forever. So it's not the highest point, but in this local area right here, that is the local max. And I love the way that this graph has named this because what's important about local max and mins is those y values. So it says the local max is 16, but a lot of times it also wants you to incorporate that x. So it occurs at x equals -2. Okay. And by the way, this is the same graph that we have on that other page when it talks about increasing and decreasing. Exact same graph right there. So similarly, a value of input where a function changes from decreasing to increasing as we go from left to right is called a local minimum. So it's changing from decreasing to increasing, that local min says it's 16 or -16. And where does it occur when x equals 2? Just like before, this is not the absolute min. This graph is going to keep going down forever. So it's not absolute, but in this local area right here, that is that local min. So together, local maxima and minimum are called the local extrema or local extreme values. A function can neither be increasing nor decreasing at extrema, which is what we talked about on this page here. That's why we're using parentheses, talking about increasing, decreasing, and constant, because I cannot say what is happening at this local max and min. Is it part of the increasing category or the decreasing? It's just excluded from it. So example 4, the numbers of any at which f has a local max. What is the local max value? So where is my local max at? Here is my max. So it wants to know the numbers at which, or sorry, the numbers of any at which f has a local max. So this one's actually asking for our x first. So here is that x equal pi over 2. The local max equals my y value of 1. The numbers, if any, at which f has a local min. What are the local min values? So here is my min. And it says at x equals -pi over 2. That's my x value. The local min equals -1. So pause the video, see if you can do example 2. Okay, so you can check your answers here. For example 5, it says at x equals 0, the local max is 3. That's right here. Here's my max. Now this one has 2 mins, right here and right here. Now because both of them have a min of 0, we can write it in this way. At x equals -2 and x equals 2, the local min is 0. If those were at different values, we'd have to say something like maybe at x equals -2, the local min is 0, and maybe this one went down to -1, and then we'd have to say And then at x equals 2, the local min is -1. So if that min is different, we have to kind of separate our sentences, but because it has the same local min, we can kind of clump them together.